Lesson 11.3 is much shorter and easier than 11.2. We're on the downhill part of this of this chapter and of this whole course. 11.3 is graphs and applications. And the first thing we're going to do is just kind of look at some sketches of some third degree and fourth degree graphs. Graphs of third degree equations with positive leading coefficient could look like this first example. Notice that this crosses the x-axis in 3 places, so this would have 3 real solutions. Another graph, excuse me y'all, could look like this, where you would only have this crossing the x-axis in 1 place. It would have 1 real solution, 2 imaginary. The end behavior is up on these. That means as it ends, it goes up. That's because it's got a positive leading coefficient. Notice that I have put little stars at these places. As you're going from up to down, when this graph changes direction, was going up and now it's going down, that's called a turning point. And again, over here, when it changes from going down to going up, that's another turning point. So notice that both of these third degree equations have 2 turning points. This one occurs at a maximum. This one occurs at a minimum. It's not the lowest point on the whole graph, but it's the lowest point in the neighborhood. If you had a negative leading coefficient, it would start up and the end behavior would be down. This is an example with 3 reals. Notice it's got 2 turning points. This one has 1 real. So if it has 1 real, it also has 2 imaginary. This one also has 2 turning points. This one is a maximum. This one is a minimum. Let's quickly look at what can happen with fourth degree. You could have 4 reals, and notice that how many turning points we got. We got 3. We could have 2 reals and 2 imaginaries. Got 3 turning points. You could have a fourth degree equation that didn't have any real answers. They could all be imaginary. It looked like this. But it still got 3 turning points. Okay. Now let's look at the page 2 of this handout. It says determine the maximum possible number of turning points of the graph. You do that by looking at the highest exponent. Notice that a polynomial degree n has at most n minus 1 turning points. So if it's third degree, it's got 2. Problems 16 and 17 say find the turning points in the given interval. And I've pointed out what the turning point is. It's where it changes from going up to going down or vice versa. So this says find the turning point for this polynomial that's between -2 and -1. Step 1, put this in your calculator. 2x cubed plus 5x squared minus x minus 6 graph. And look at it. Does it have a turning point between -2 and -1? Yes, right there. Now, what are the coordinates of that point? We want an x comma y answer. So you're going to go second calc. This is a maximum. Press maximum. Move your cursor to the left of that point. Notice it says left down here. Press enter. Move the cursor to the right of that point. Notice it says right. Press enter. It asks you, do you want to guess? No, you don't want to guess, so you press enter again. round this answer to 2 decimal places, and I got negative 1.76, comma, 0.34. Negative 1.76, comma, 0.34. You've got the complete instructions to do this. Just follow those instructions. I don't think you'll have any trouble. Just be sure that you know what the turning point is. That's the turning point. Let me do those. Let me go through that one more time. Second calc. We're looking for a maximum on this one. Move to the left of it, press enter. Move to the right of it, press enter. We don't want to guess, press enter. That's my answer. If they were asking me to find this other one, it would be a minimum. I'd go second calc. I'd go to minimum. I'd move over here. I'd press enter. I'd go under there. I'd press enter, press enter. And the coordinates of that point are 0.09, comma, negative 6.05. They didn't ask me to find it, but that's what it would be if they did. The third thing on this page that we need to do is they've given us some graphs and they want us to find the equation of the graph. This is a little more involved than what we have done before. In the preceding section, they just gave us the answers and they said find the equation. Now then, they're giving us the answers and they're also telling us where it crosses the y-axis. So you're going to start with f of x equals a times x minus x1 times x minus x2 times x minus x3. These places where this crosses the x-axis are your x1, x2, and x3. The point where it crosses y is your x and y. You know that f of x is the same as y. So 9 equals a times 0 minus negative 5 times 0 minus 3 times 0 minus 6. 9 equals a times 5 times 18. 5 times 18 is 90. Divide both sides by 90. A equals 1 over 10. Your answer is f of x equals 1 over 10 times x plus 5 times x minus 3 times x minus 6. Let's do this little extra problem. I'll just point out that on this extra problem, we have a graph that just touches at 2. So this is x1, this is x2, and it's also x3. Crosses the y-axis at 2. So 0, comma 2 gives me my xy. I'm ready to substitute all of those values in. I have 2 equals a times 0 plus 3 times 0 minus 2 times 0 minus 2. I know that that will be 2 equals 3 times 4 is 12, 12a. A equals 1 over 6. Final answer, f of x equals 1/6 times x plus 3 times x minus 2 times x minus 2.